Hi, I'm just going to go through the flow of the program, the car starter program, and I'm going to do it in 3 short flash videos just to break it up a bit. And this part is just going to be, I'll zoom in here. And we're just going to show the first time power on, power up for the car starter. It just goes through this part here, initialize ports A and B, and then goes to sleep. And this is for the PIC 16F84 chip. And then the second part is going to be, it's going to be woken from sleep by 2 inputs. Well, actually, it can only be woken by 1 input, and it always has to be start button 1. And what it's going to do, it's going to know that it has to go to Tach Learn in the beginning. It's got to learn the idle pulse rate for the off the tach wire or the primary ignition coil, and it's going to measure the number of pulses on port A pin 4. That's the real-time clock counter, and it's a Schmidt trigger, and it's going to count up to 6, roughly 6 or 7, and that's just one example. You know, it could be different from car to car, but in our example we're going to use 6, and it's going to count 6 over the course of 1/5 of a second. And then when it's finished doing that, it's just going to when it's finished, the Tach Learn, it's just going to flow back up. The program flow the chip is just going to go to sleep. That's what it's going to do. It's going to power down and go to sleep once it's learned the tach rate and written the value to EEPROM at EEPROM memory location 00. And then it's going to go back. It's going to go to sleep and wait for an external interrupt from. Again, it has to be the start button 1 from the keychain transmitter through the RF receiver decoder board and to the PIC chip. So we'll get started. I have MPLAB IDE version 8.73 open, and we're going to use the project wizard. Our chip is the 16F84, and it just needs to know where your assembler, linker, and librarian are located, where on your hard drive, so it needs that path location. We'll tell it to store locations in the project. Next, we'll tell it where to store and give it a name. And now we add the files. There's our main program, car211.asm, our defines, and the tach counter, 2 main subroutines stored there, check tach and fast learn, and that's it. And select our simulator. It's MPLAB simulator, and we'll open a workbook that I've created already, and it's on the disk as well, rcstarter.sbs. And we've got our asynchronous input for simulating pulsed input on port B pin 0 and 7 and port A pin 1, which is the brake input. And these are our RF keychain transmitter buttons. Button 1 is there, and button 2, and then the brake input. And we also have to reduce it from 20 megahertz because I'm using an RC crystal oscillator. We're going to clock the chip at 4 megahertz, not 20. And so we should be good to go. We'll open up our ASM files and we'll be able to see the program pointer stepping through the program with the animate button. That's this one here. Or we can, just set a breakpoint and let it run flat out with the run button, and that way we can get through many iterations of a delay routine that way. So we have to build our program. So we'll clean, save the project, and tell it to build all. And we have many warning messages. That's okay. The build was successful. We can see that the build was successful. And we'll just put that away for now. Okay, and we're ready to go. We're initializing. We're initializing ports A and B and configuring option register, and it's just going to go back to sleep. Let's power down. It's asleep. And one thing that we have to do is we have to ensure that two things are true before we get it to learn the Tach rate. So we go view file registers. File registers 5 and 6 are where our break input and button 1 are latched. So in file register 5 we need at least a value of 2 because it's pin 1 on port A and pin 0 on port B for the start button. And if we're going by the binary system, pin 1 is not pin, it's next to pin 0, then it's 1, 2, 4, 8, and so on. So we're going to need at least a value of 2 because it's the break input is on pin 1, and at least a value of 1 on file register 6 because the transmitter, the decoded transmitter button 1 is on pin 0. So 1 here, at least a 1 here, and at least a 2 here. So we'll see if we can make that happen before we get started. So we have a break, there's our break on and our transmitter button 1 on. And it's looping away here in check Tach. So we'll just kind of, we'll set a breakpoint here at the end of it. And we'll step through it. Step through it here with step into. We're coming back here. It's going to call fast learn, and we'll do something neat here. We're going to go to, we'll step up. It's going to call check Tach here, and we want to find out how long. It's supposed to be 1/5 of a second. I know it is. I'll just prove it here with the stopwatch. We'll zero out the stopwatch, and we'll just hit run. Oh, okay. And we see that 200 milliseconds have passed. That's how long it took to get from the beginning of the delay to the end of check Tach. And we'll just step. And now this is the part where it goes to write the value, and the value that it recorded is going to be in the W register, and we'll see that in special file registers. Special function registers, sorry. And we'll just take a look at EEPROM. You can see that this is where it's going to write it to, location 00 in data EEPROM. Right now there's an FF, hex FF in there now, but it should be seeing 6 or 7 in there soon. I'll just set another breakpoint here. Let it rip through that. Step out of that. Set another breakpoint. Rip through that. Take it off. And we return from fast learn. We're out of the loop. And here we've got another one here. Delay 200 milliseconds. We can even time that one if we wanted to using the watchdog, or sorry, the stopwatch. There's our value in EEPROM. It's written. That's the number of pulses it counted in 1/5 of a second. And that's it for this video. Thank you.